Welcome back to my channel, Math and Language, and we're going to discuss secant-secant segment theorem. Let's start with the introduction. If two secant segments are drawn from the same exterior point, then the product of the lengths of one secant segment and its external segment is equal to the product of the lengths of the other secant segment and its external segment. So let's start with having the figure first. So we need two secants. So we have secant BC and another secant that is secant AC. Now, you may have noticed that they intersect at the point and they form an exterior angle. The formula for this one is the whole secant, that will be AC, will be multiplied to its external segment, and that will be BC. Is equal to the whole secant of the other one, the other secant, and multiply to its external segment, EC or CE. So again, the variables depends on the figure. So I just want to say that this one, the whole secant multiplied to its external segment is equal to the other secant multiplied to its external segment also. Let's start with the example. Example number 1, you have a given AC is equal to 8. The whole secant is 8. And BC, the external segment, that will be 3. And CD, the whole secant, this one, that will be 12. And CE, that will be X. Because that is our goal, to find what is the value of CE. Let's start. So we have the formula AC times BC is equal to CD times CE. You have the whole secant, the first whole secant is 8, and the external segment of that whole secant is 3. So this one, this 8, and this part only is 3. And that will be equal to the whole secant of the other, that is 12, multiply to its external segment. That will be x, because we don't know. The 12 and x here. So let's simplify it. 8 times 3, that will be 24. Is equal to 12 times x. 12 times x, that will be 12x. And the value of x, that will be 2. And there you have it. That's easy. Next one is, okay, so let me show you. The whole secant is 12. The smaller one means the external segment is 2. The whole secant of the other one is 8. And the smaller part, the external segment is 3. Moving on. Let's have example number 2. What if we have a given AB is x? So this part is x and BC is 5. And the other one, CE, the external segment of the other secant is 4. And the internal segment of the other secant is 6. How are we going to find the value of x? We don't know the measure of the whole secant of the two. So what are we going to do? AC, this one, you just add AB and BC. AB is x, so that I'll put it here, and BC, that will be 5. So that will be, this whole thing is x plus 5. Now for CD, the value of DE, this one, is 6. And EC, or CE, is 4. So that will be 6 plus 4, or that will be 10. So because we already have the whole secant, the two whole secant, we can place the formula and solve for x. So AC, that will be x plus 5, and BC, that will be 5. CD, that will be 10, and CE, that will be 4. Let's simplify it. The quantity x plus 5 multiplied to 5, that will be 5x plus 25. And it's equal to 10 times 4. 10 times 4 is 40. And let's simplify it further. Subtract 25 to both sides. That will be 5x is equal to 15. Divide both sides by 5 and you will get x is equal to 3. So let's put 3 here. AB is 3 and AC is equal to 3 plus 5. So that will be 8. So there you have it. So the whole secant for AC, that is 8, and for the whole secant of the other one, that will be 10. Let's go into the last example. Let's have another complicated one. AB is equal to 6. So the internal segment of this one is 6. AC is x. So the whole secant is x. CE is 2, and the whole secant is 8. Okay, so we're given, we have the two secants, the measure of the whole secants. However, we don't have BC. We don't have BC. How are we going to find it? So here's the, so for BC, we have x minus 6. Remember, the whole measure of this secant AC is x, and the other part of its secant is 6. So we can say, to find this one, you just subtract it. That will be x minus 6. So that, because we already have the parts for our formula, we can solve it. So AC, that will be x, BC, that will be x minus 6, and CD, that will be 8, and CE will be 2. Let's simplify it. X times the quantity x minus 6, that will be x squared minus 6x. This is equal to 8 times 2. So simplify 8 times 2, that will be 16. Now we will have a trinomial here. Just move the 16 to the left side, and you will get x squared minus 6x minus 16 is equal to 0. Let's factor this one. A factor of x minus 8, the quantity x minus 8 multiplied to the factor of x plus 2 is equal to 0. So to find the value of x, that will be x is equal to 8 and x is equal to negative 2. Remember, in measurement, you cannot have a negative value. So we will only accept the answer, the positive answer, which is x is equal to 8. So let's simplify it. So AC, that will be 8, and this one will be 8. 8 minus 6. So BC will be 2. And there you have it. And as you may have noticed, it has the same value. Segment AC has the same value with BC. So AC is 8 units, and CD, segment CD, is also 8. And that's the end of the lesson on how to solve secant-secant segment theorem. And if you would like to comment or suggest another math and language video, or if you have assignments or questions, I'll do my best to answer those questions. Just comment down below. Again, this is James, your math and language instructor. Please like and subscribe, and also click the bell notification so you will be updated for my future videos about math and language. Thank you, and I'll see you again. Goodbye.